Hello dear aspirants of JEE Mains. Today in this video we are going to deal with the topic which is transformer. But before we start actually the discussion of and working of the transformer, you should know how the power is transmitted, which is generated from the power station and which reaches up to you as a consumer. So here I have the block diagram of the power transmission system. So power is generated in a power station and that power is carried away with the help of these wires, and such transmission wires can carry the power, that is the electrical power, and it reaches up to the consumer. So the consumer may be an industry, it may be a town, it may be a village, it may be a farm, anything, or heavy industry. Then here you can observe these T's. So these T's, they are nothing but they are the T's for transformers. So here for the instance, keep in mind that this transformer which is used to transmit the power, it is a step up transformer. We will discuss why step up, and then according to the purpose, here we have the step down transformers. So here the step down transformer has a different kind of a rating for a heavy industry. For light industry, the step down transformer is of different rating or different configuration. For town it is of different configuration, for village it is of different configuration, for farm it is of different configuration. So here for each purpose, that is a consumers, we have different type of step down transformers, while for the transmission of the electrical power which is generated in a power station, we use the step up transformer. We discuss this why later. So before we proceed, you should know that the electrical power can be transmitted in both the ways, that is AC as well as DC. So there are some advantages and as well as disadvantages of both the systems. So earlier it was only the DC transmission. So sometimes ago the electric power transmission was in DC due to the following advantages. So there are 2 conductors used in DC transmission, while 3 conductors are required in AC transmission. There are no inductance and surges in DC transmission. Due to absence of inductance, there are very low voltage drop in DC transmission. Then there is no concept of skin effect in the DC transmission, therefore small cross sectional area conductor is required. Then in DC transmission there are no difficulties in synchronizing and stability problems. So these are some of the advantages of DC transmission, but at the same time there are the disadvantages of DC transmission as well. So due to commutation problem, electric power cannot be produced at high DC voltage. That is one of the major problem for DC transmission. Then for high voltage transmission, we cannot step the level of DC voltage because the transformers cannot work on the DC. Similarly, we cannot step down the DC voltage with the help of transformer, because again the reason same, that is DC cannot transformers do not work on the DC. Then there are some other we are not much concerned about it. Then for AC transmission, nowadays the generation is transmission and distribution is mostly in AC. We do not use the generation, transmission and distribution by DC. Nowadays we use it in AC only. So there are obviously the advantages of AC over that of the DC transmission. So the advantages are AC circuit breakers is cheaper than that of the DC circuit breakers. The repairing and maintenance of AC substation is easy and it is expensive than that of DC substation, and the level of AC voltage may be increased or decreased, that is step up or step down, with the help of transformer. This is our advantage of AC. And why it is advantageous? Because for DC there is a limitation of the distance. We cannot generate the power in a power station and transmit the electrical power to very larger distances, say 1000 kilometers away. from the power station, but that can be possible with the help of AC. So this is the main advantage of AC transmission, and that is why for AC transmission we require the transformers, that is the step up and step down transformer. So again, this is the block diagram for the transformers in the transmission system. So here power is generated with the help in a power station. Then such power is step up, that is the voltage of the voltage is increased with the help of step up transformer. Why, we discuss later. Then such high voltage is transmitted through the transmission cables, power cables, and which are usually made up of conducting material. And then with the help of a step down transformer, the again voltage is reduced, and then finally it is provided to the consumer. Now let us discuss the problems in the transmission. So let us consider that there is a power plant which usually generates a power of about 1000 watt, and with the help of the transmission cables it has been received up to the consumer. Now if we assume that resistance of the wire is, say, suppose 10 ohm, where L is the length of the wire, then the formula for resistance is R is equal to rho L by A. Now where A is the cross-sectional area of the wire, it may be constant. Rho is resistivity of the material, so it also remains constant. And L is the length of the wire. So as the length increases, resistance of the conductor increases. So here resistance of these transmission cables, it increases with the length, and therefore over the larger distances, since the resistance is more, and therefore it gives rise to the power loss, and that power loss is of the order of I square R, where I is the amount of current which flows through the transmission cable and R is the resistance. Now you know that this power can be written as voltage multiplied by current. So if I say that this is the 1000 watt power, then this 1000 watt can be written in terms of voltage and current as say suppose 500 volt and 2 ampere current, or it can be written as 250 volt voltage and 4 ampere current, then 100 volt and 10 ampere current. So ultimately the product is 1000 watt and the power is 1000 watt. But what will happen if we have the values of voltage and current like this to that of the power loss? So for the first case, if I consider that the current is 2 ampere, then my power loss will be 2 square, that is 4 into 10, where 10 is the resistance of the wire. So 4 into 10, that is 40 watt is the loss in the power, and therefore the power which is reached is 1000 minus 40 watt, that is 960 watt. For the second case, if I consider the second case, that is voltage as 250 volt and current as 4 ampere, then the I square R loss will be 4 square, that is 16, multiplied by 10 ohm, that is resistance. So it is 160 watt is the loss. So the power which is reached at the consumer end, it will be 1000 watt minus 160, that is 840 watt. And if I consider the third case, that is if my voltage which is generated at the power plant is 100 volt and 10 ampere is the current, then considering this current as 10 ampere, so 10 square, that is 100 into 10, that is 10 ohm resistance, so that is 100 watt is the loss in the power, and therefore power reached to the consumer is 0 watt, because 1000 watt is generated, 1000 watt is lost, and therefore 0 watt is the power which is received at the consumer. What does it means? What these figures show? It shows that if the value of my current is minimum and voltage is maximum, then the loss in the signal is minimum. So if I keep on reducing the value of current and if I keep on increasing the value of voltage, then it is beneficial, because in that case I can reduce the power loss, and that is the reason why the power which is generated, because we require that whatever the power which is generated, all the power should reach to the consumer end. We should not lose in between, and in order to avoid that, the power is transmitted in such a way that we keep the value of current to be as minimum as possible and maximum voltage as possible. And so that is why we need to increase the voltage, and in order to increase the voltage we require the step up transformer. And that is why for power transmission, the power which is generated in the power plant, that is being transmitted with the help of a step up transformer. So we increase the voltage and reduce the current, while at the consumer end we cannot use such high voltage, and for that purpose we require the step down transformer. So that is the function of a transformer. Now you might have seen such type of big transformers in a power station which is nearer to you in your town. If you have a look at the power substation, then there might be the transformers of such size. Then if you look at the construction of a transformer, then this transformer is basically consists of laminated core which is made up of iron or soft iron, and then such laminated core of soft iron, it actually consists of large number of plates stacked, and then here on this side you see a coil which is wound onto it. It is called as the primary coil, and there is another coil which is wound on the other side. It is called as the secondary coil. So if we are going to give the input to these coils, so they are such coil is called as a primary coil, to which we are going to give the input, and from the coil which from which we are going to get the output, such coil is called as the secondary coil. Now what is the basic principle of working of a transformer? So in case of a transformer, mutual inductance is the basis of all types of transformers. So a transformer is a device which is used for changing the voltage of alternating current from low value to high value and vice versa. So if it is increased from low value to high value, then it is called as a step up transformer, and if it is decreased from high value to low value, then it is called as a step down transformer. So we can see the transformers by the roadsides in villages and cities. Whenever the magnetic flux linked with a coil changes, an induced EMF is induced in the neighboring coil. So that is the principle. So in a transformer there are two coils, that is primary coil, I refer this as P, and the secondary coil I refer it as a S, which are insulated from each other, and they are wound on a soft iron core as shown in the figure. So the primary and secondary coils, they are called as the input and output coils respectively. Now when an AC voltage is applied to the primary coil, the current through the coil changes sinusoidally, causing similar changes in the magnetic flux through the core. As the changing magnetic flux is linked with both the primary and secondary coils, EMF is induced in each coil. The magnetic flux linked with the coil, it depends upon the number of turns in the coil. So if an alternating current, if an alternating voltage is applied to the primary coil, then sinusoidally it causing similar changes in the magnetic flux through the core. So here the magnetic flux is produced in the iron core, and since the magnetic permeability is very high, as well as the magnetic susceptibility is greater than 1 for the soft iron core, and therefore it will not allow the magnetic flux line to move out of the iron core, and therefore it will keep the magnetic flux inside the iron core only. So such changes in the current, it will cause the change in magnetic flux, and such change in magnetic flux is linked with the another coil, which is the secondary coil. So whenever the magnetic flux lines get changed in a coil, then it also induces an EMF. So it is called as the mutual inductance. So the change in magnetic flux lines in the secondary coil, it produces the induced EMF.